So, I've talked a little about the process of measurement, but I've made it sound a little as though we just decide what it is we want to measure, pull a few instruments out of the air, and hey presto, we're done. It will be no surprise to learn that it's not quite as simple as that. For any measure we contemplate using, we have to think about whether it is valid and whether it is reliable. Validity and reliability in this context are somewhat technical terms with well-specified meanings. Let's start with validity. If we're concerned with the validity of a measurement, we're asking, does the measure accurately reflect the concept it is meant to measure? If we're concerned with reliability of a measure, we're asking a different question. We're asking whether a particular measure applied to the same object on different occasions yields the same result each time in the event that nothing of relevance has changed. In essence, reliability is about consistency. In order to be valid, a measure must have some degree of reliability. To see this, consider a completely unreliable measure. If repeated applications of the measure are uncorrelated with each other, then what is being measured, in inverted commas, is random noise, and random noise can't be a valid measure of anything that we are likely to be interested in. It is, however, not true to say that reliability presumes validity. A measure can give consistent readings when applied on multiple occasions, without it actually indicating anything about the concept of interest. If I give a French vocabulary test to a set of school children on one occasion, and then administer a similar test on another occasion, I would expect the scores to be correlated, indicating a degree of consistency. This would not, rather obviously, make a French vocabulary test a valid measure of mathematical ability. Let's think a little about how we might evaluate reliability. Given what I've said, an obvious approach would be a test-retest method. In other words, we pose the same questions to the same subjects or respondents on several occasions. If we're feeling particularly sophisticated, we might also arrange for the questions to be asked by a different interviewer on each occasion, to rule out the possibility that any apparent similarity simply reflects an interviewer bias. Of course, test-retest methods have their drawback. We sometimes can't use exactly the same instrument on each occasion, especially if the period of time between the two administrations is short. If we are evaluating the mathematical ability of a set of children, we wouldn't ask them literally the same questions on each occasion, but try to use near equivalents. Naturally, if the period of time between each administration is long, then we run the risk that the underlying reality may have changed, and thus the apparent unreliability of a measure is actually a manifestation of true underlying change. We might also have a problem if subjects react to the testing process. We know, for instance, that the takers of cognitive ability tests get test-wise. In other words, their performance improves the more time they take the tests, partly because of increased familiarity with what is expected of them. We can't induce amnesia in human subjects, so the assumption of ceteris paribus of the test-retest setup is weakened. If a test-retest approach to reliability assessment is impractical, another approach is available. This relies on examining inter-item reliability. The easiest way to explain this is with an example. The idea is to use in parallel, at one time point or in one administration, more than one indicator of the same underlying construct. Let's say that we're interested in measuring trade union militancy. We might come up with a couple of equivalent measures of the idea. For instance, we might get our respondents to respond to items like, "I'm opposed to strike action under any circumstance," and alternatively, "I could not vote for strike action regardless of the facts and circumstances of the case." If certain assumptions are satisfied, then reliability can be quantified as the correlation between responses to the two items. In circumstances where we have more than two items, then the idea can be generalized by examining the average inter-item correlation. While, at least in principle, it is possible to specify a precise measure of reliability, there is no simple way of quantifying validity. This should perhaps not be too surprising. When we're concerned with reliability, we're concerned with the consistency of two or more observables. By definition, when we're interested in validity, we're concerning ourselves with the correspondence between observables, our indicators and their measures, and an unobservable, the underlying construct. Clearly, we are going to have a hard time if we expect to definitively demonstrate the validity of a measure. However, this does not mean that the enterprise is completely hopeless. There are in fact some ways that we can gather evidence relevant to a judgment about validity. The first thing we might examine are simple face validity and content validity. This requires nothing more than asking ourselves whether the measures we propose to use seem, on the face of things, to be about the sort of things that are likely to be indicative of positions on the underlying construct. For example, if I want to know how people are aligned on the liberal authoritarian dimension, asking them whether they think it is appropriate to ban the publication of books that a large proportion of the population find offensive has more intuitive appeal than asking them whether they prefer to shop in Waitrose or Tesco. Of course, this sort of thinking deeply about what you are trying to measure approach, though obviously useful, is only going to get you so far, especially if opinions differ as to what a given item really indicates. To end this section, I want to discuss two other approaches, called here criterion-related validation and construct validation. Neither approach is foolproof, but both offer the possibility of learning more about one's measures than simply waving one's hands in the air and merely asserting that our proposed measures happen to be valid. Let's first talk about criterion-related validity. What I'm going to assume will at first sound a little weird, but bear with me, and I'll give you an example where this sort of approach has been useful. We want to measure concept A, and we're in the fortunate position of having a gold standard measure, which we'll call the criterion measure. It turns out, however, that it's very expensive or impractical to collect information on the criterion measure. Perhaps it requires highly trained interviewers or observers. Perhaps it requires considerable respondent motivation or cognitive engagement or memory to provide the information that is required. It's also possible that someone might come up with a cheaper, simpler alternative that does not overburden the respondent. Naturally, we would want to know whether such a measure was valid. The obvious way to do this would be to examine the correlation between the proposed new measure and the gold standard criterion measure. Naturally, we would expect this correlation to be non-trivial. Now for an example. It's common to construct measures of social class from the occupational titles of people's jobs. This inevitably is a somewhat indirect way of going about things. Not all jobs with the same title are themselves the same, but it has the advantage that information about a person's occupation is relatively easy to collect. Imagine that in a survey we collected both information about a person's occupation, but also on those features of their job that we would regard as indicators of social class, measured at an individual level. It would be unlikely that we would have the latter routinely available to us in anything other than a very specialised survey, but if we could establish a fair degree of correlation between social class when measured at the level of the individual job and social class when measured at the more aggregated level of occupations, we would have gone some way towards establishing the latter as validly measuring the underlying construct. Now let's turn to construct validity. This is a much more hazardous enterprise, and depending on how things turn out, the conclusion that you can draw may be ambiguous. The starting point here is a well-established theory that leads one to believe that concept A is predictive of concept B. We have a tried and tested measure of concept B, and we're interested in evaluating the validity of a proposed measure of concept A. Let's make things more concrete by giving concepts A and B names. Let's say that there's a well-established theory that leads us to expect the existence of a close and confiding relationship with a significant other protects people from serious depression. We have a well-tested and widely used measure of the symptoms of depression. We also have a newly proposed measure of the degree of closeness and confidingness of a relationship. We wish to know whether the latter is valid. An obvious move would be to see whether our proposed new measure does indeed predict depression. If it does, then we have a modest amount of evidence to support its validity. If, however, it doesn't, or predicts it in the wrong direction, it's unclear what we should conclude. Perhaps the problem is not that the measure is invalid, but simply that the theory is wrong.